Alright. Hey guys, what we're going to be doing today is talking about writing series in summation notation. Okay, so first off, summation, alright? That should make you think of this Greek letter epsilon, alright? Or sigma, I forget which one it technically is, okay? It looks something like that. I'm not very good at writing it, but that is vaguely what it looks like. To give it a more precise look, let's see if I can't find it. Well, I thought for sure it'd be in here. Okay, well, now I'm just wasting your time by doing this, but it's this guy right here. I don't know why I can't find it in here. It's a Greek letter. I should have done this before the video. But now y'all get to watch me do this. Why is it not in the Greek letters? It's a Greek letter. It's a Greek letter that gets used all the time. Okay, well, never mind. I don't want to waste any more of this video. Sorry about that. This is it's math. Aha! Here it is. It's in math. So it looks like this. Okay? So, what this guy is it's just summation. Okay? That's what this symbol means. When you see this symbol, it means to sum up. Alright? And then down here, you just take your variable. So a lot of times the variable is n, I, k. And you just say, hey, I want to start n equaling to 1. So what that means is, hey, I just want to start the first term. If for some reason you didn't want to start the first term, you wouldn't put a 1 here. You'd put a 2 if you want to start the second term. Alright? And then up here at the top, you just put the total number of terms that you want. Okay? So we're going to do this example. Alright? So then the total number of terms I want for this problem is 25. So up here I just put a 25. And then right here you just write the explicit formula. You don't actually put EF. Right now I'm just putting EF as a placeholder. You write in the explicit formula. So really the only work you have to do to find the series in summation notation is figure out the explicit formula. And we just spent like a week and a half talking about how to find explicit formulas. Alright? To find explicit formulas, you first have to ask yourself, is this a geometric situation or is this a arithmetic situation? Okay? So you look at this 35, 25, 15, 5, ... Hopefully, I'm not meaning to draw at the moment. Hopefully you realize that I'm obviously subtracting 10 each time. Okay? So that means I have a common difference. So the common difference is negative 10. Okay? So that means I need to write the explicit formula assuming it's arithmetic. Okay? So then the explicit formula for arithmetic, and if you just don't have this anywhere in your notes, write this down. But the explicit formula for arithmetic, before you plug anything in and simplify, is just a sub n is equal to a sub 1 plus d times n minus 1. Okay? So then all you have to do is take this a sub n and then make it equal to, okay, so what was our first term? Well, our first term was 35. So 35. Alright, what was d? D was negative 10, so minus 10 times n minus 1. Okay? Now, you need to distribute the negative 10n to both things, so you're going to get 35 minus 10n plus 10. Okay? So, 35 and 10 you have together, that gives you 45, so you get 45 minus 10n. Bam! That's my explicit formula. 45 minus 10n. So over here, I'm going to erase EF now, because what I'm actually going to put here is 45 minus 10n. 45 minus 10n. Bam! That is this series written in summation notation. Okay? Guys, that's really all there is to it. I'm going to do one more example, but genuinely, that's all there is to it, okay? Simply write your summation, your epsilon, set whatever variable you're using equal to 1, assuming you want to start your first term. If for some reason you want to start at a different term, you just say n equals 5 if you want to start at the 5th term. But how many terms you're going to, alright? And then just write your explicit formula. So the only real work you have to do is remember how to write an explicit formula, which just means you have to ask yourself if the series is arithmetic or geometric. If it's arithmetic, you just plug and simplify. There you go. Alright, so let's do one more example. Okay, so here's our next example. 1 plus 0.5 plus 0.25 plus 0.125. Okay. is this arithmetic or is this geometric? And you look at it, you might say, I'm really not entirely sure. Okay. So first off, ask yourself, how would I get from 1 to 0.5? Oh, subtract 0.5. Okay, how would you get from 0.5 to 0.25? Would subtracting 0.5 work again? Hopefully you're like, no, that would not work. Because 0.5 minus 0.5 would be 0, not 0.25. Okay, so you're like, alright, so it's probably not arithmetic. Well, it's definitely not arithmetic. So you think, okay, is there a number I can multiply 1 by to get to 0.5? If you really don't know, you can check it on your calculator. Okay, by just simply saying 0.5 divided by 1. Okay, so that got me 0.5. Now, let's check to make sure that if I did, so I did second term over first term, let's check to make sure that I could also do third term over second term and get the same answer. Okay, and I do, I get 0.5 again. Now, instead of using 0.5, I'm going to use 1/2, but you'll notice each time I'm multiplying by a 1/2. Okay, so r is equal to 1/2. So, I know it's geometric, and I want to write this series in summation notation. So, I draw myself my summation symbol, okay? We're going to use the variable n again. It really doesn't matter what variable you choose, but I want to start the first term, so n equals 1. That's a weird looking n, but that's what it is. Alright, how many terms is there total? Well, don't say 4, because you see these dots at the end, that means it keeps going. But you'll notice I don't give you a certain number to stop at, so then it goes to infinity. Alright, so you want to put an infinity symbol on top here, just representing that it goes on forever. Now we need to put in our explicit formula. So then we need to figure out what our explicit formula is. Well, we have to ask ourselves, what kind of form was this? Was this arithmetic or geometric? It was geometric. So you should remember, but if you just don't remember or you don't have it written down anywhere, geometric explicit formula can be written like this. A sub n is equal to a sub 1 times r raised to the n minus 1. Alright, so then for this problem, a sub 1 is 1 times r, which was 1/2, raised to the n minus 1. Alright, now hopefully realizing multiplying by 1 isn't going to do anything, so I'm just going to drop it. I'm just going to write 1/2 raised to the n minus 1. So then that is our explicit formula. So then, right here, next to the summation, you put in 1/2 raised to the n minus 1. And there you go. You're done. That's it. That's literally all there is to it. Just that right there. Okay? So we're going to do one more example because it's just kind of a fun problem. Alright? So let's look at it. Okay, so here's the last problem I'm going to look at. Here's your series. 5 plus 5 plus 5 plus 5 plus 5 dot dot dot. Okay, so I said I want you to write this series in summation notation. So you need to draw yourself your summation symbol. You need to put your, we want to start, let's use the variable n. So we say n equals 1. What's the total number of terms? Well, dot 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 means it keeps going, so we draw an infinity. And then the next question we ask ourselves, is this arithmetic or geometric? Well, 5 times 5 to go to 5? I just multiply by 1 each time. But wait, in geometric, r can't equal 1. That's like one of the first things we talked about is how r cannot equal 1. And it's not arithmetic, so what do? You just write the number 5. Because are you changing 5 at all? No. Literally every term from 1 to infinity is just 5. So the first term is 5. The second term is 5. The third term is 5. So bam, that's all you have to do. This is written in summation notation. Alright, it's just kind of a clever thing. Just something to be aware of. I just think it's kind of cool. Most of you probably could figure that out without me saying it. But I just wanted you to see it. Alright? Alright, let me know if this video has any errors. Let me know if you have any questions. Alright.